Welcome to Spitfire Mods. This is a video on the Honton HT-R490. The unit is currently doing a reflow on an Xbox board. The board had a red rings of light, or R-rod, red ring of death, and this is a modified or custom 50mm nozzle, which is used because it gives you a good buffer zone around the chip so that you can isolate the chip real well, get a good temperature. We're probing just under the edge of the GPU to monitor our component temperature. We also have a modified lower heater pickup and a board sensor, temperature sensor to monitor the board temperature, as well as a lower airstream monitor probe. This way we actually can monitor the entire system throughout the repair so that we can make sure that we're getting a good liquid state on our solder. And then the machine over here is actually graphing the GPU component to make sure that it reaches a temperature high enough to liquefy the solder underneath the component. And what you'll see on typical profile is a nice preheat stage to warm up the board, and then it'll climb up into a soak phase to get the flux activated. There's a little bit of a slump there for the soak, and then it's going to climb up into the liquid state and hold that for about 30 seconds and then come back down out of that liquid state. This machine is good for doing unleaded boards, primarily because of the upper airstream, hot airstream. The lower nozzle underneath right there, we can actually heat up the board beneath the chip so that when it's getting near the liquid state, it can climb up to almost 300 degrees Celsius for a short period of time, allowing the board to superheat hot enough to actually allow the upper unit to not have to put too much heat on the GPU, which prolongs the life of the GPU, so that after the repair your board will have a long-term life cycle still. Underneath this board there's not really much components right under there other than some surface mount, small surface mount components, resistors and capacitors. As you can see, we're reaching into the 220s now, which is our liquid state, so at any point now we're going to want to start leveling off and then cooling the board down. So right about now we're going to switch the unit heat off, which will let the unit climb back down. And then we're going to want to hit the fans and let the board cool. Raise the nozzle for the cooling cycle. And right now the system is flushing out that heat with the cross flow fan here, which is built into the unit, which cools the board down so that in about 5-10 minutes we'll have a nice room temperature board to remove, and a nice drop in the graph to solidify the solder after we've liquefied it. Also, we can take a snapshot of this profile so that we can save it for future reference. So that we can keep a record of our customers, so that should a board return, we have an exact pattern of what heat was run on it. If it has a relapse, we know that it may need more heat, and if it has other failures, we know that the profile might be causing damage or some other problem. So keeping records on every machine allows us to cater the profile to the exact type of board that the customer has when they originally send it in, and having thousands of boards run through the shop, that allows us to know exactly what type of profile is going to do what to each board.